Hello friends, welcome to Secret of Electronics. In this video we will learn how to make a overload protection device using a Arduino Nano board and a current transformer. The overload protection circuit uses a Arduino Nano board and a current transformer to monitor the load current and disconnect power if a overload is detected. The current transformer senses the AC current, which is rectified and filtered by R1 and C1 before being fed into the Arduino's Nano analog input pin. The Arduino processes this signal and, when a overload is detected, sets D to high to drive transistor Q1, which activates a relay to disconnect the load power at J4 connector. Buttons connected to D3, D4 and D5 with pull-up resistors R6 to R8 provide up, down and reset functions to control set points or restore operation after a trip. A SSD1306 OLED display shows real-time current readings and system status, making the circuit suitable for AC load protection. Lib used for measuring AC current with a current transformer. It calculates RMS current easily. Bayer I2C library for communicating with the devices like the OLED display. Adafruit underscore GFX and Adafruit underscore SSD1306 libraries to control the OLED display. EEPROM allows reading writing values to the Arduino's non-volatile memory so the threshold is remembered after power off. Defines screen size for OLED. Initializes the OLED object with I2C communication. CT underscore pin reads the AC current by the current transformer. Relay underscore pin controls the relay that cuts off the load if overload occurs. BTN underscore up, BTN underscore down buttons to adjust the overload threshold. Reset underscore BTN button to manually reset the overload trip. Creates a object Emon1 to read AC current using Emon threshold current, default overload threshold in amps. Calibration factor. Calibration for the CT sensor. Adjust for your CT ratio and burden register. EEPROM underscore ADDR. Memory address in EEPROM to store threshold. IRMS measured current in real time. Last threshold stores previous threshold to detect changes for EEPROM updates. Trip latch keeps track of whether the relay has tripped, latches the overload condition. Relay pin setup. Set relay as a output and turn it off initially. Button setup. Use internal pull-up registers. Input underscore pull-up for buttons. They read low when pressed. Serial begin for debugging on serial monitor. OLED init starts the OLED. If it fails, halts the program. Emonlib init sets up CT sensor on A0 with calibration factor. Load threshold from EEPROM reads saved threshold. If the value is invalid, none or out of reasonable range, reset to 2M. OLED setup clears display and sets text, size and color. Reads AC current RMS value by sampling 1480 times. Checks if the current exceeds the threshold and the relay is not already tripped. Latches the trip and cuts the load by turning the relay on. If the reset button is pressed, clears the trip latch, turns the relay off, restores power, adds 300 millisecond delay to debounce the button, ensures that once tripped, relay stay off until reset. If not tripped, relay follows normal operation. Adjust threshold in steps of 0.1 amp using up and down push buttons. Prevents threshold from going below 0.1 amp. Adds 200 millisecond delay to debounce buttons. Saves threshold to EEPROM if changed significantly greater than 0.05 amp. Avoids excessive EEPROM writes. Clears the display and prints current measurement, threshold value, system status, normal, overload or tripped. Prints the same information to serial monitor for debugging. Now connect the Arduino Nano board to your PC or laptop using a USB cable. After connecting, open the Arduino IDE. Once the Arduino IDE is open the code file which you can download from the link provided in the description. Before uploading, make sure the required libraries are installed. I have already installed all the necessary libraries, so I will skip the library installation section. Next, select the correct board and port from the Tools menu. After selecting the correct board and port, click the Upload button in the Arduino IDE to upload the code to the Arduino Nano board. Once the upload is complete, disconnect the Arduino Nano board from your PC or laptop. Finally, connect all the components according to the main circuit diagram we discussed at the beginning of this tutorial. Now you can see that I have connected a 15-watt LED bulb as the load. At this time, the bulb is on and the current is displayed on the OLED screen. Next, I disconnect the LED bulb and connect a 100-watt bulb. As you can see, when I connect the 100-watt bulb, the relay is activated and the load power is cut because the bulb draws current above our threshold. Now I disconnect the 100-watt bulb and reconnect the 15-watt LED bulb. After connecting it, the bulb does not glow because the overload protector is still tripped. To restore operation, press the reset push button. After pressing the reset push button, the LED bulb turns on again. We can also increase or decrease the threshold current using the up and down push buttons. After increasing the threshold, if we connect the 100-watt bulb, it will now glow. If you liked this video, then do not forget to subscribe to our YouTube channel to watch more interesting tutorials.